Good day once again, ladies and gentlemen, and we are back together and we're looking at probability this time around. If you haven't subscribed, please just make sure you're part of the family. And of course, you can always become a member and, just benefit from those wonderful perks that we have. All right, so let's jump into this question. I know most of you, get heebie-jeebies on this section, but really it isn't much of a challenge. You can go and watch our playlist on probability, and you'll see that it's actually something that's quite understandable. Right, so they say to us we've got A, B, and C, which are three events, whatever those events are, right? The probabilities of these events are, or any combination of them, occurring is given in a Venn diagram below, right? So now you can see there you've got that Venn diagram there, and they say to you, if it is given that the probability of at least one of the events at least one of the events will occur is 0.893, calculate the value of. All right, so initially they want the value of y. Now, ladies and gents, so this tells you that this sample space, okay, or in this case, when we're looking at, these events, right, they are not exhaustive, right? What does exhaustive mean, right? It simply means that they exist within just these elements in this case, and that there's no other possibility of it not happening. So in this case, the probability of A or B or C would have been equal to 1 if they were exhaustive. But in this case, we realize that we still have, it's actually 0.893, so which means there is a likely event that none of the events will happen, okay? So in this case, we say that they are not exhaustive. All right, let me not talk much. So they say calculate y, the probability that none of the events will occur, right? So what are the chances that we will have none of the events occurring? In this case, I want you to note, right? They had told us that 0.893 is the possibilities of at least one of them happening. So that means that we're going to now say, all right, the possibility that none of them happen would be 1 minus 0.893. And what does that give us? 1 minus 0.893. That will give us 0.107. I guess if you want to convert that to two decimal places, you can say this is 0.11. Okay, so that's the possibility that none of them will occur. Right, let's go to the B part of this. Right, they say the probability that all three events will, or rather, calculate X, right? The probability that all three events will occur, right? Now, I want you to note that within, or rather, when we look at the probability of A or B or C occurring, right? Now, what are we looking at? Remember, when we say or, we are including everything, right? So it means that we're going to look at A or B or C. In this case, this includes everything within our sample space. Well, not within our sample space, within the elements, right? So in this case, we're looking for the value of X, but now we know that the probability of either one occurring is 0.893. So all we're simply going to do is add everything up, and it must give us a sum of 0.893, right? So I'm going to just remove that so that it doesn't disturb us later. I just wanted to illustrate that to you. I hope that makes sense, right? So now we're going to take all right, so let's say this is going to be X is going to be 0.893 minus, now let's add everything up, right? Let's go to A first. That's 0.05 plus 0.1 plus 0.15. That will give me in A alone, that will give us 0.3, right? So 0.1 plus 0.15 will give us 0.25 plus an additional 0.05. That will give me 0.3 plus, let's go to just B, and remember not to count the same thing twice. I've already counted these two, okay, these three rather. Okay, so now it's going to be the probability of B, that's going to be that and that. So remember, because I've already counted that, I'm not going to include that. So that will be 0.83 plus 0.2, which will be 0.383, right? So that's 0.383, 383 plus. In this case, now I'm looking at C, right? Remember, I've already included that and that, so I'm just going to take that 0.05. Okay, so that's 0.05. All right, so let's do that quickly. So that's 0.893, and we subtract in that 0.3 plus 0.383, 83 plus 0.05. Okay, that gives me a value of 0.16. So it means that X is that value of 0.16. I hope that makes sense, ladies and gents. Right, now they say to us, determine the probability that at least 2 events will take place. Now let's go back to our data set. Now the probability that at least 2 events will take place. Now note, at least 2 events would be the probability that it's A or B, right? Or in this case, you can say the probability that it's this would be B or C, right? Or B and C rather, not B or C. B and C, right? Yeah, maybe I should have illustrated that with a different color, right? So B and C, so I'm going to go into that. Or the probability of B and C, which is that in green, or the probability that it's A and C, which is that in blue over there, right? So in this case, we're just looking at those possibilities, right? So that's the probability that at the very least, right, we will have 2 events taking place. Right, so that was 10.1.2. Okay, so I am going to say, right, so the probability that we've got 2 events, at least 2 events, okay, now we will say, right, now let's go back. So that's going to be that 0.1 plus X plus 0.2 plus that 0.15. I hope you can see that, right? So that is 0.1, right? We said plus the probability, X there, we got it to be 0.16. This is plus between B and C, that was that 0.2. Remember, we've already included X, so 0.2. And in this case, we also have the probability that it's A or A and C. In this case, that would be 0.15. Okay, right, and let's add that up. Okay, let's see. So we already have that 0.16 plus 0.1 plus 0.2 plus 0.15. Okay, I get a value of 0.61. That is the probability that at least two events will take place. Right, okay, so we get to the last portion of it, right? Now, they say, so are A or are events B and C independent, right? And they want us to justify our answer. Now, ladies and gents, you'll see that I've covered the issue of independence, quite extensively, right, in the longer lessons. Now, what do we know when events are independent? We know that if they are independent events, if I take, right, now I want you to note, if I were to take the probability of A and, the probability of the other, the probability of the one plus and the probability of the other, I'm just mincing my words, right? We're looking at B and C, so the probability of B and C, so I'm going to say the probability of B and C. If B and C are independent events, then it means that the probability should be the probability of B multiplied by the probability of C. In that case, if this is equal to that, then we can conclude that our events are independent, right? Now let's do this. Let's find the probability of B on its own, right? So let's go back. The probability of B, that's 0.183, 0.2, 0.1, right? As well as X, okay? So we can add that up. So that's 0.183 plus 0.1 plus the 0.2 plus the X, which is 0.16. Okay, so the probability of B is 0.643, right? So let's write that on its own. We said that's 0.643. Now let's take the probability of C, right? And again, when we look at C, right, we are going to have that 0.05, 0.15, we're going to have 0.2 as well as that X. Okay, maybe it's better if I use a different color, right? Right, so we said it's that 0.2, 0.05, 0.15 as well as X. Okay, right, so we're looking at the probability of C. So okay, let's add that up. Let's go back there. We said 0.05 plus 0.15 plus 0.2 plus, in this case, X, which is 0.16. And I get a value of 0.56, ladies and gents. So that's 0.56. Now, I've got the probability of B and the probability of C independently, right? Now, then I go to my Venn diagram and say, well, what is the probability of B and C? So I'm looking for this left-hand side, right? Probability of B and C. So I need to go back and look at my diagram. Ooh, I've painted it, hey? Right? I look at the probability of B and the probability of C. I'm just going to take a different color in this case just to illustrate that, right? Probability of B and C. Okay, now that color is not quite visible, right? I'm going to take this one, okay? So probability of B and C. So it will be that X value, right, plus the 0.2, okay, right? So that would be the probability of B and C. So the probability of B and C will give me 0.16 plus 0.2, which gives me 0.36. Now, I know what this is, right? Now, let's find out if when we multiply this, do we also get the same value? So I'm going to take probability of B multiplied by probability of C in this case. So that's going to be 0.56 multiplied by 0.643, right? So let's find that out quickly. 0.56 multiplied by 0.643, right? I mean, we can say 0.36. It gives us 0.36, right? 0.36. Now, what do you notice, right? We can therefore conclude that A and B are actually independent. So, I mean, B and C rather. So, B and C are independent, right? But why is that? Okay, right? Because the probability of B and C is equal to the probability of B multiplied by the probability of C. I hope that that made sense, ladies and gents. Right? I am going to treat fundamental counting principles next in a separate video so that they don't become long. I hope that is helpful. I'll see you again. Sharp, sharp.